Okay, one last one, guys, for the week. This one is going to be on the quotient rule for exponents. But what I wanted to start with was one more example from the last lesson. I realized after I taught the lesson that I hadn't really explained to you the why. I taught you how to add the exponents, but I didn't teach you why we do it. So this is one of the examples from the previous lesson. So as you can see, we're multiplying between these two terms. And obviously, we are still going to multiply 3 and 5 to get the 15. And then what I had told you to do was to add, with our base of x, they are obviously the same. So then the power of 6 and the power of 2 would be added together to give us 8. So here is the y. If I was to break apart 3x to the 6th power, it would look like this. 3 times x times x times x times x times x times x. And the 5x to the 2nd power would be 5 times x times x. So same thing. We multiply the 3 and the 5 together. So when we multiply this x times 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 x, that's the same thing as x to the 8th power. So basically all you're doing is adding up all of your x variables to give you an x of 8 to the 8th power. So that's the y. So moving on to the dividing, which is the quotient rule for exponents. You're probably already thinking, well, if I'm adding with multiplication, I'm probably guessing that I'm going to be subtracting with division, and if that's what you're thinking, you are right on track. So this is how this works. So division in algebra typically it looks like a fraction. The fraction bar is our division sign. So the numerator, we have a to the 4th power times b to the 7th power, divided by a to the 1st power, which we've talked about, times b to the 2nd power. So the way that this would work, the a's are the same base. So what you would do is you would take your 4 and you would subtract your 1 to leave you with a to the 3rd power. And same thing for the b's. The b's are the same base. So you have a b of 7th power and the 2nd power. So you would do 7 minus 2, which would give you b to the 5th power. So that seems probably pretty simple. So over here, I kind of broke it apart because I wanted to show you why we're subtracting. So when I broke apart a to the 4th power, we have a times a times a times a, and b to the 7th power was b times b times b times b times b times b times b, divided by a times b, because b times b is b squared. So when we divide, what we do is we divide our likes, our sames. So we have a divided by a, which actually would be 1, which cancels it out. And then we have b divided by b, which does the same thing. B divided by b is 1, which cancels it out. And then we do it again here, leaving us with nothing else on the bottom. So as you can see, I had 3 more a's on the top than I had on the bottom. You see how I have 3 left over? Because 4 minus 1 is 3, leaving me with 3 left over. And over here, I had 5 more b's on the top than I had on the bottom, which leaves me with b to the 5th power. And as you can see, as I pull out here, that I get the same thing. So this is how 4 minus 1 is 3, 7 minus 2 is 5, and this is the y. These a's canceled out, these b's canceled out, leaving me with 3 a's and 5 b's. Okay, I am going to skip the second example on this paper because none of the other questions on that paper are like that one. And maybe when we come back next week, I will go over that more in depth because I feel like it's a little bit more complicated. And like I said, none of the other questions on this particular paper look anything like that. So in an effort not to confuse you and overwhelm you, I'm not going to go over that one right now. So don't worry about that one. So I'm going to go to letter A. So what we have here is 2 times k to the 4th power divided by k to the 3rd power. So it's basically like saying 2 divided by 1, which leaves us with 2. And I have 4 k's on the top and 3 k's on the bottom. And like I said with division, we're going to subtract. 4 minus 3 is 1. Or you can think of it as I have 1 more k on the top than I have on the bottom, leaving me with nothing on the bottom. And which you do have something on the denominator. It'd be 1, but we don't have to write that. Okay, moving on to letter B. So we look at our integers. We have 3 divided by 3, which is 1. Again, we don't have to write that, but if it makes you feel better, I'll go ahead and write the 1. And we have, this one is a little bit different because as you can see, I only have 1 y on the top. And I have 4 y's on the bottom. So yes, 4 minus 1 is 3, but here's the thing. I have 3 more y's on the bottom than I have on the top. So the 3 y's are going to stay on the bottom. Because if I was to break that apart, and you know I will, as I think about it, I probably should go ahead and do that. Because it does start to get a little bit more complicated. And I'm just breaking it apart so I can show you why the 3 is on the bottom. Because what happens there is these cancel out. So I don't have any y's on the top. The 3 remaining y's that I have are on the bottom. Because like I said, I have 3 more on the bottom than I have on the top. 4 minus 1 is 3, but the 3 are on the bottom of the fraction bar. It's still part of the denominator. So with the x's don't have any friends. So he has no one to subtract with. So what I have here is 3 x's on the top and 3 y's on the bottom. And now to rewrite that, I'm going to go ahead and get rid of that 1. And this is what the final answer would look like. There you go. So one more. I know you probably are going to need many more examples, but I'm going to just do these 3. And again, if you need more, let me know and I will be more than happy to do some more. Okay. So we have the 3 here. 3 divided by 1. I'm just going to leave him as 3. He doesn't have anyone to divide with. So he kind of stays there. I'm going to get a better marker. All right. So I have 1x on the top. And I have 2 x's on the bottom. So that leaves me with 1 more x on the bottom than I do. I'm going to go ahead and draw this out. I have 1 more x on the bottom than I did on the top because 2 minus 1 is 1. So 1 on the bottom. The guy on the top is gone. So then we have a z on the top and a z on the bottom. So this is z to the 1st power and this is z to the 1st power. So basically what happens here, 1 minus 1 is 0. They cancel out. Or you can think of it as z divided by z. That's 1. He goes. He's gone. So now I have y to the 2nd power divided by y to the 2nd power. So the same thing kind of happens that happened here. You can think of it as 2 minus 2 is 0, which makes the entire thing become 0 and go away. Or you can think of it as y squared divided by y squared is 1. And when it becomes 1, it also cancels out. So what I'm left with here is 3 over x. And let me write that to make that a little bit better looking. 3 divided by x is what that would look like. Again, if you have any more questions, please feel free to reach out.